Hello 242. In this video I want to talk a bit about measuring ventilation. The process of measuring ventilation is called spirometry. The instrument used in spirometry is the spirometer. A spirometer measures airflow into and out of the lungs. It can measure the rate of airflow, and it can also measure the total volume of air moved. These tests can detect asthma, emphysema, chronic bronchitis, and other conditions that affect ventilation of the lungs. When using a spirometer to measure lung volumes, the data is recorded on a graph. The graph shows time in seconds on the x-axis. And lung volume in milliliters on the y-axis. When you breathe in, the spirometer records it. When you breathe out, the spirometer records it. Breathe in and out, quiet, normal, unthinking breathing. The amount of air breathed in this quiet breathing is your tidal volume. Think of the tides coming in, coming out, coming in, coming out. Typical tidal volume for an adult is around 500 milliliters. If you take your tidal volume and multiply it by the number of breaths you take in a minute, BPM stands for breaths per minute, you get your minute ventilation. Minute ventilation is the total volume of air you move through your lungs in 1 minute. Now, after a few quiet breaths, take a deep breath. Inhale as deep as you can. Get those accessory muscles working. Now exhale as strong as you can. Get out as much air as possible. The additional air you were able to take in that forced inspiration is the inspiratory reserve volume. To find the IRV, ask how much more air can I take in beyond the tidal volume, and measure from the peak of quiet inhalation to the peak of your forced inhalation. That's your inspiratory reserve volume. The additional air you were able to breathe out in your forced expiration is the expiratory reserve volume. To find the ERV, ask how much more air can I breathe out beyond the tidal expiration. So you measure from the bottom of a quiet exhalation to the bottom of your forced exhalation. That's your expiratory reserve volume. The total amount of air your lungs can move is your vital capacity. In adults, it's typically about 5 liters, more if you're tall or an athlete or male, less if you smoke. On the spirometry graph, you can measure the vital capacity directly, from the high point of the forced inspiration to the low point of the forced expiration. See how your vital capacity incorporates your tidal volume, plus your inspiratory reserve volume, plus your expiratory reserve volume. If you add all 3 of these volumes together, you get your vital capacity. The vital capacity isn't quite all the air in your lungs. No matter how hard you exhale, you'll always have some air trapped in your lungs, deep in the alveoli and in your conducting zone structures. They never fully close. The air left over in your lungs, the air that can't be moved, is your residual volume. This spirometry graph summarizes all of the lung volumes that we've discussed. You have tidal volume, inspiratory reserve, expiratory reserve, vital capacity, and residual volume. After studying this video, you should be able to define spirometry and identify the clinical usefulness of a spirometer. Define tidal volume, minute ventilation, inspiratory reserve, expiratory reserve, vital capacity, and residual volume. Identify each of these volumes on a spirometry graph. And explain the relationship between tidal volume, inspiratory reserve, expiratory reserve, and vital capacity.